Right, today we're going to study missing numbers. I have let's begin with the first question. Okay. So the question, if you do when you do the homework, you will see like that. Okay, as one circle or triangle represents n digits. Okay, so let me check. Yeah, for example, 7, 6. We have a number here missing, 5 plus another number missing, 47 equals like that. Okay, and you have to fill in each box with a digit. Okay, now when you do this problem, then you have to write, you copy this number, okay, and then you put here and add them together, and you write it like this. Okay, so it's kind of equation. You have 4 unknown numbers here, and you have to solve it step by step. Okay, but this is so you have to find the starting point. This is the first problem is easy to find the starting point. Of course, 5 plus 7, right? 5 plus 7 is going to be 12. So is the first step. You got 12. Okay, and you got, right? So you got 2 here. Okay, right? You got 2 here. So now once you get 2, and you have to add another one here, right? Then look at the second column. Okay, so there's this unknown number plus 4 plus 1 cannot be just 11, cannot be just 1, right? Definitely it's 11, right? So it's 11. So that means what is that number? That number must be equal to 6. So every time you are solving an equation, so that number is going to be 6. Okay? So once you get 6, then 6 plus 4 plus 1, it's 11. So you move 1 to the front. Okay, just step by step, you can figure out the details. Okay. All right, so now let's do this next one. So you have 6 plus this unknown digit, plus 1 should be equal to 2. I think it's more than 2, so it's definitely going to be 12, definitely, because it cannot be 22, right? Because the largest possible digit would be 9. 6 plus 9 plus 1 is 16. So it's clearly this number is going to be 5. So you get 5. Okay. So once you get that, then the rest of them is easy, and the final answer will be 8 here. This is 8. Okay. So step by step, you go this way. Yeah. So you go in this direction. This is let's use a yellow, right? From here to here, and then from here to here, and finally you get this. Okay. So you figured out this is your path. Sometimes you do not start with the last digit. You will start from middle someplace. Okay. Okay. This is similar to the puzzle. You played with a puzzle before, and so you have to find the right piece first, then gradually figure out the rest of them. Okay. But every time you have to solve an equation like that. This is the equation, right? This is the equation. Okay. So our next problem is going to be 6. Okay, and here plus 2 and plus 3 and the 1 and the 5. Okay, you get the 1 9, 0. Okay, how many unknowns here? 4. Okay, can you try? You see, what is your first number? Right, what is your first number? You can figure it out. Okay, you write down this on the piece of paper. Right, write down this on the piece of paper, and try to figure it out. The first one, then the second one, then the fourth. Right, some students already got the answers. Okay, that's good. Okay, so let's see, how do we do it? I think we still can look at the last digit, right? The last digit is going to be this plus 5 cannot be 1. The next one is to be 11, right? So then you get, that will be 6, okay? So your first number is 6. Then you add 1 to here, then you get another equation. That equation plus 1 should be equal to, I think, cannot be 19. First one you try 9, the next one will be 19, and I think cannot be 19. So clearly that should be equal to 7. That's our second number, right? Now sometimes you have multiple solutions, okay? Could be 9, could be 19, okay? Then no numbers move up, right? So then the third one will be 6 plus this number should be equal to 0. Cannot be 0, right? Because it's already larger than 6. So it should be 10. Okay, so you get that number should be equal to 4. So you put 4 here. Okay, step by step. Okay, you put 4 here. 4 plus 4, right? So you get 4. Then you have to add the 1 here, right? So 3 plus 1 is going 2 plus 1 is going to be 3. Okay, so you go in this direction from here to here and to here, and then finally figure out that number. Okay, so 676 plus 2415 plus 2415 is going to be 3091. Okay, so you have 3 equations to solve. Those are 3 linear equations we call, right? Unknowns, right? Yeah. Okay, you get 3 equations. Good. Okay. So the first problem is similar to the second problem, right? You start from the unit digit, and one by one, you go further to the left. You figured out all the unknown digits on the way, right? The next one, I'm not sure we still use the same strategy. Okay, minus subtraction now. Okay, we got 2,000. Oops. Okay, 2,856. Okay, can you work on that? I hope you can figure it out by yourself. Okay. This is a subtraction. Remember, it's not addition. Okay, now subtraction, there are a couple ways to do. Okay, I'm going to show 2 different ways to do to solve this problem. Okay, maybe as a direct way, just say how can I get 6, the units digit, right? A single digit minus 7 will not give you 6. You have to borrow 1. So it sounds like start is getting trouble here. Okay. Let's try. Okay, let's try. So you have, yeah, you have to borrow 1 from this side, right? So it's going to be subtract 1, right? So you have a 1 here, right? A 2-digit number minus 7 equals 6. So that digit must be what? Must be, right? Must be 3, because 13 minus 7 is going to be 6. Okay, so you figured out which is going to be 3. Okay, now you already lost 1 digit, 1, right? From the second one. So when you do the subtraction, that's the first one, right? When you do the subtraction, this number already subtract 1, right? Yeah, minus 1. Then minus 1 should be equal to 5. Okay, should be equal to 5. Should be equal to 5. Then, and you can see that that number must be equal to 7. Okay, so you get 7. Okay, you get 7. Okay, so you figured out the second one. Okay, the third one, 0 minus some digit equal to 8. 0 is a small number, right? It's 0. You have to borrow 1, so it becomes 10. Then minus 1. So 10 minus this unknown digit should be equal to 8. Okay? So 10 minus this unknown digit should be equal to 8. That unknown digit should be equal to 2. Right? Then you get a 2, step by step. So now the last one. The last one is this unknown number. You already lost 1 digit. Minus 3. Minus 3. Okay, is anything under that, right? I remember, yeah, this is a 2. It's missing. The digit is missing here. It's 2. Okay, 2, 8, 5, 6 disappeared. So, so that unknown, that should be called 2. Right? So that number is going to be, okay, is going to be 6. Okay. So that will be 6. Okay. So we solve the problem. We still go step by step, right? We step by step, you're going from here, right? And then to here, and then here, and then that number. Okay? Right? You figured out that. But if you feel difficult to deal with subtraction, maybe you can do a different way. Okay, why? How do you do a different way? Well, you can see that some number minus 3 of something, right, is going to be 2,856. So why not just 2,856 plus, use a plus, and then you get that number. It'll be probably much easier. Okay, right? So you see, A minus B equals C. A should be equal to C plus B. So subtraction become addition. If you do become addition, then the problem will be much quick. Then you can quickly solve the problem. See, without solving so many questions. Okay, how do you do that, right? So you already see that. That's a piece of cake now. Right, 6 plus 7 is going to be 13. So add the 1, then that will be immediately get to 7, right? Then 8 plus something should be equal to 0. That must be 2, right? Then add that, then you plus 1 here. So that'll be 6. You see, within 1 second, couple seconds, you get all the answers. So you can convert the subtraction to an addition. Okay, this is what I want to tell you. All right. Okay, now our next problem. Okay. So we are we're trying to given this, the sum of 2 digits is going to be 169. Okay. Find the sum of 4 missing digits. Okay, just add them together. Okay, in other words, if you have a, just add them together, figure it out. Maybe I cannot figure out the individual digits, but I can still add them together. Okay, that's not a unique solution here. Okay, but the answer is the sum of the 4 digits, missing digits, will be the same. Okay, so there are a couple ways to do. One is to find a special solution, a specific 4 digits can fill in. Okay, then you get to 169. Okay, and that's easy, right? So we can you can put one example here, but in mathematics, this probably not the perfect way to do. The reason is, how about the other solutions, right? How to get a 9? One example, right? One example, I can say 3, 6, so I get a 9, right? And then 8, 8, right? I get 16. That's okay, right? So the answer will be 8 plus 3 plus 8 plus 6. Okay, so that will be 25. That will be 25. But this is always true or not? Right? You haven't proved it. So in mathematics, sometimes we call so-called prove it. This should be always true. Maybe different students give me a different 4 digits. Okay, I have here 1, 8, right? And then I also have as I put a 9 here, and then have a 7. Okay, I still get 169. And when you look at this, 9 plus 1 plus 7 plus 8, that's still 25. Okay, there are many ways to do that. Okay, I tell the truth. It's not unique. Okay, they're not. Yeah, there are lots of different ways to do this. So the question is, how do you how do you say that this is always the same? Give you the same some answers. Okay. Let's think about this. Okay, how do you prove that in mathematics? So you have an A, right? A and the B and the C and the D, add them together, 169, right? 169. And are you able to? Yeah, are you able to get right? So think about how do you get a 9, right? B plus D, that is a 9, but cannot be 19. Why cannot be 19? Right? Plus B plus D cannot be 9. But why cannot be 19? Because B is a digit. D is digit. Maximum value of digits will be 9. 9 plus 9 will be 18. So cannot be 19. So that's it. Then C plus A must be 16 from this expression, because nothing came from B plus D. If it's 19, B plus D is 19, then you also get the 1, right? From that, from that. But you don't get anything from B plus D. So A plus C must be 16. So there are multiple solutions for Bn plus D, right? There's so many of them. If B plus D, right? B plus D equals 9, then B could be 0, D could be 9, and then B could be 1, D equals 8, and keep going. So I just said that there are how many solutions? 10 different solutions, just for that simple equation, B plus D. Okay, but we don't need to worry about that. What we need to know is the sum is going to be. So B plus D plus A plus C is going to be just 9 plus 16. So that's why it's always equal to 25. That is called mathematical proof. Okay, we don't use a specific examples to prove the statement. Maybe you're trying 2 different, solutions here. You end up with 25. Then you jump to the conclusion, hey, the answer is 25. Yes, the answer is 25, but your solution is wrong. What is the difference between solution and answer? Answer is just one number. Solution, all the detail work. Okay, so the solution is incomplete. Okay, but the answer is correct. Okay, so that's why when I ask you to do the homework, I don't want to see the answer only. Okay, you have to show the details how to get this answer. This is also your ability. It's very important. When more advanced math you study, and then you have to learn this, you have to know how to express your ideas clearly. Okay, sometimes very complicated project, you end up with the wrong answer. But in computer science, call like a debug, decoding, right? You find the bugs, where's wrong. And if you do not show the details clearly, nobody can figure it out. It takes much longer time. Maybe you have to rewrite it again. So it's very important to show the details. Okay, so this is a solid proof. All right, good. Our next problem will be, right? Our next problem will be, okay. So here, each letter represents a digit, but different letters, they represent maybe different digits, but the same letter represents the same digit. Okay, A, B, A, B, A, B, C. Okay, and then you have A, B, C, D. So you got 2001. Now this actually was a problem created by some teacher in 2001. Okay, and then right, we're trying to find out A plus, what is the question? Okay, the question is, yeah, we're trying to figure out all the digits if possible. Okay, this is a complicated case. All right. Yeah, we have to find A, B, C, D. Okay, so each represents a digit. A digit means one from, okay. All right, so you guys don't type anything on the screen, okay? Listen, okay? If somebody did something wrong, you don't need to say anything, okay? Then that's the only person will make troubles. If you repeat, follow it, okay? Then get too much garbage messages on the screen, okay? All right, so those are digits, And think about that, okay? All right, so we have to find out A and B and C. So what is a starting point? What is a starting point? Okay. You cannot look at the last digit. A plus B plus C plus D should be equal to 1 or 11 or 21, right? Or 31. There's so many possibilities there. Okay. So what is the easiest part? I think the first, okay, on the left-hand side, right? Now A equals 2 or A equals something. Maybe A equals 1 because you probably get one digit from B plus A plus B. Okay. Oh my God. Just a second. You think about this problem, okay? What? Hello? 我在上课。Okay, fine. All right, so let's look at this problem. All right, I don't know what's going on with my pen. Let me check. Okay, I say my hint is you try to figure out A first. Okay, from the left hand side. Okay, A could be 1, could be 2. Okay, so first of all, you have to say is that 1 is impossible. Okay, and A equals 2 is impossible. Let's try this, right? The maximum value for A is going to be, right, if A equals 2. Why this is impossible? If A equals 2, that means this is the first part, right? That's the first part. So nothing came from the previous computation, right? A plus B. Then A plus B should be, okay? A plus B, you have to get a 10, okay? Then that's impossible. Why? Since, yeah, from here, you see A plus B should be equal to 10. Then you give a, should be, no, A plus, sorry. If A is 2, nothing came from, you cannot get, yeah. So A plus B cannot be 10. Okay, the reason is if A plus B is 10, then A is going to be, right? You have to give a 1. Let's see. Let me try to figure it out. Okay. So for, let's do this way separately, okay? If A is 2, but A plus B should be 10, right? Because you got 0 there. Otherwise, A is 0, B is 0. That's impossible, right? Since you already say A is 2. But then this implies B is going to be, okay? This is going to be 8, okay? Right? Let's see. So you just step by step to solving back, right? Then B is going to be, if A is 2, B should be equal to 8, right? Yeah. Do you think it's possible that B is 8? So step by step, okay? Now if B is 8, A is 2, so A plus B, okay? And A plus B, Yeah, if see, this is a contradiction now. If A is 2, A plus B plus something is going to be maybe plus something from the previous, okay, plus 1 or 2, okay, it's possible, is 10. Then you get to 1, you add it to that, so you get 3, so it's impossible, okay, this is clear. So you have to say that, it's impossible. Okay, think about why it's impossible. That's a logical problem here. Impossible. Okay, why is it impossible? Let me assume that, okay? If A is 2, so nothing came from the previous, but A plus B cannot be just 0. A plus B maybe plus another 1 from the previous computation, right? Then you should get 10. Then once you get 10, then you get 1. So A plus 1 then becomes 3. That's contradiction. So you must, yeah, this conclude that the only possible solution for A is 1. Okay, then you step by step. Okay, then you step by step to get the remaining. Okay, so be careful when A equals 1, then when A equals 1, how do you get 2 there, right? So A plus B, that's 2 possibility. A plus B could be, if A is 1, the maximum value for B, right? We know. So you have to contribute 1 to A here. So must be 10. So 1 plus 1 is going to be 2. Okay, must be 10. Okay, now there's a possibility A plus B plus another number from the previous one, right? You don't know. No, there's a contribution from A plus B plus C there, right? So let's work out here. If A plus B, okay, is 10, okay, then B is going to be 9. Looks good, right? Step by step, okay? So B is 9. Then you have a, let's try to find this one if we have a solution. If B is 9, so let's look at our picture, okay? So we have you have a 1, 1, 9, 1, 9, C, 1, 9, C, and D. I get 2001. Okay, so what you can get from here? Do you think it's possible or not? Sometimes it's at the end. Then you have to go to other options. Okay, so do you think it's possible? Okay, so 1 plus 9, I think it's impossible. Look at this. Look at this. 1 plus 9 already is 10, plus C could be 10 or larger, right? So C must be 0. Then you get, that's impossible, you know? That's impossible. You stop here, it's dead end, okay? So another option you will get is from here is B equals 8. B is 8, okay? Then you write down here, so 1, 1, 8, 1, 8, C, 1, 8, C, D. So sometimes you have, like a tree, you know, this way, that way, okay? Then you can figure out the rest of 3 digits, okay? And you can easily to see that, okay, C should be equal to 1, and if C is 1, then D must be 1 too, okay? So that's why you solve the problem. Okay, got it. Let's go back. How do we solve this problem? Sometimes like case 1, case 2, you have to step by step. Our starting point is A, okay? You have 2 options. A could be 2, you know, but then you find out, if you look at the second column, A plus B, okay, equals 10, or A plus B plus 1 equals 10. Either way, it's impossible. Okay, because you are going to A plus B equals 0. That means A plus B, A plus B plus 1 equals, it must contribute 1 to the other part. Okay, so that's why it's impossible. It's easy. Then you A equals 1 step by step. A equals 1, you have 2 possibilities. And A plus B equals 10, that's dead end. I just said that. A plus B plus 1, where is 1 from? 1 is from this computation, from A plus B plus C. It's clearly can get 1. So that's why you, then it works. It worked out, okay? So it's a little bit challenge, okay? So we're going to look at the next one, okay? BA, CBA, DCBA, and EDCBA. And add them together, I got 2,000. Okay. And can we find A, B, C, D, E? Okay. Right. So what is the starting point? I think still the starting point is the starting point is still E. Okay. Okay, because the E is short. Okay, E could be 2, could be 1. I think we can just assume that if E is going to be, what? Is going to be 1. If you do like that, I'm not sure you can work out. Maybe it's not doing well. Okay, so if this is a special case, if we use the same idea, it could be 1 or 2, right? If it is 1, that means you have to get another one from the D, right? Then you have to, and I think it's getting more complicated. So you have to get to 1 from here. But this is not just only 1. This could be D plus some number equals that. So I think it's getting difficult when I do the primary computation. Okay, let's stop there. Then you think about, is there any other better way? Okay, is there any better way? Well, you look at last column. Okay, you look at last column. You have 4 numbers, add them together equals 0. Okay, 4 numbers. How do you get 0? 4 digit, right? A plus A plus A plus A. In order to get the last digit, it could be 0, 10, 20, right? I think that's it. That's a 3 possibility here, right? It's a multiple, yeah. You get the last digit, right? Can it be 30 or not? It's impossible. So only possible situation here is could be math is hurting, right? So could be 20, but this 10 is impossible because 4s equals 10. I don't think it's get 10, so it's impossible. That's possible, okay? That is also possible. And the 30 is not possible. 40 is not possible. So that's only 2 possibilities here. Okay, that's only 2 possibilities. So you have to divide. Then you try. Once you figure out A, then you can get B, then you get C. Okay. So if you have to figure out whether A is possible or not. Okay, A is going to be 0. Yeah, A is going to be 0, and here A is going to be 5, because 4 times 5, it's going to be 20. Okay, So you have to look at either case. So let's do this problem. When A is 0, do we think it's possible or not? So B0, CB0, and DCB0, and then you have E DCB0 and get 0. Okay, 0, 0, 0, 2. All right. Okay. Well, this is it's getting a larger tree here, right? Okay. Yeah. The other one is the other one will be B5, CB5, DCB5, and EDCB5. And you get 0. Now you have to add 2 here. 0, 0, 0, 2. But we don't know which side will get into the dead end. But you end up with the same situation. Okay, you have a 4b here, right? You have a 4b here, right? So it's a b plus b plus b plus b. You can have 2 cases, either 0 and 5. And I'm pretty sure 0 is impossible here because this is 20, yeah. B equals 0, that's impossible. B equals 5. But why is it impossible? Because we don't write a 2-digit number, 0, 0, okay? So you only have one choice, okay? So now let's keep going. That's pretty C50 and the DC50 and the EDC50, okay? So now we can quickly get 0, 0, and then plus 2, right? So, so I think D plus what you can get. Can you get C? I think C is going to be quickly. You can see that C is going to be 6. Then D is going to be D plus 2, 2D plus 2. It's actually is going to be 4. Okay. Then E is going to be 1. So from here you can quickly figure it out. So there's indeed a solution here. Okay. There's indeed a solution here. Okay. Yeah, I give some steps. You know, when you come to this point, it's easy to see why the 3C plus 2 should be 10, should be 20, right? And I think the only possible way is 20. Then C must be 6. Then C gets 6. Then you get 20. Then 2D plus 2 should be 0, should be 10. So that's why D is going to be 4. Then you get E. Okay. So that's how to get all the numbers. Now, my question is, do you think the other side is possible or not? What do you think? Okay. Do you think the other side is possible or not? Maybe not. Okay. Okay. The reason is you have a 5b, right? 4 plus b plus 2 should be equal to either 0, that's impossible. So you can 10, 20, 30, right? And 40, right? So 4b plus 2 is 8. It's impossible. 4b plus 8, yeah, b is going to be 4b equals 8. B is going to be 2. Okay? And that second one is impossible because 18 divided by 4 is and this is possible, that possible. So in that case, B is 2 or B is going to be 7. Okay? So then you probably end up with no solutions. right? So you can keep a try. I just give you one solution here, and I'm not going to continue. Maybe you can work out. We have a time, okay? Maybe you can work out. Okay, when B is 2, what happens? Then can you figure out C and D? Okay. So when you B equals 7, are you able to get C and D and E? Okay. Maybe that's dead end in each case. Okay. So this is how do we do that? Okay. So let's try and this is a little bit complicated, right? Okay. Let's try the next one. 9A 0 B 4 minus C 300D equals 7E 95. Now I told you before, if you use a subtraction, you can change it to the addition. Okay, that makes it easier. The addition says that this is equivalent to saying C300D and plus 7E95, and this is supposed to be 9A0B and 4. Okay, and then from here you can quickly get the answer. Okay, why? You see 5 is larger than 4, so D plus 5 should be equal to 14 immediately. Right? B plus 5 should be equal to 14. Okay. Then you get to D equals 9. Okay. So you give me 9. Okay. Okay, please don't type, okay? It takes time to figure it out. Okay, this is a math, okay? And yeah. So 9 plus 5 is 14, right? Okay. Now once you get 14, then you have to plus 1. Then immediately you get B, because 0 plus 9 plus 1 equals B, right? Equals B something. So what is that, right? B is going to be 0, because it cannot be 0, so it's 1B. So that implies B is 0, okay? Then you add the 1 to the front. So E plus 1 equals 0. 0 plus E plus 1 should be equal to 0, so definitely 10. So that implies E is going to be 9, right? Then you add the 1. Then 3 plus 7 plus 1 is going to be 11. So that implies A is going to be 1, right? Then you add the 1. C plus 1 equals 9. That implies C equals 8. So that's how do we solve the problem. It's not that difficult. Okay. 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 So if we convert it, the subtraction to an addition, you will get yeah, you will get solution quickly. Okay. So let's look at the next problem. Okay. So next problem, just only 2 digits, okay? AB and the BA and AB, add them together. You get CAA, okay? Each letter represents 1 digit, okay? We have to find out one number first, okay? Then the remaining will be simple. If we can determine B or A, right? If you can determine 1 over A, then you have a problem, okay? You can, you cannot figure out all the letters? Well, just look at the last column, okay? You will see that you want to see A plus B plus B. That's two possibilities here, right? You want to get last digit as A. Either you get A or you get 1A, right? You know, A could be 2, right? Then should be 12. Then you get a digit. But if it's the first case, A plus B still get a digit A, then that implies B0. It's impossible. As this implies B0, impossible because B cannot be 0 because this is a two-digit number. So the only possible case is this one, okay? So 1A means what? Means 10 plus A, right? So, okay, A plus B equals 10 plus A. So what does that mean? B plus B should be equal to 10. So that implies B should be equal to 5, okay? So let's see, we figured out B. We don't figure out A yet, but we get the B, okay? So that's a possible solution. 5A, A5, A5. I'm supposed to get A, and the C. So now I'm going to get, okay, so how can I do that? So look at the second column. Look at the second column, look at this, okay, what do we get? We get the one from the computation of the units digit, right? Because A plus 5 is 10 plus 8, so that's 8. So now you get 5 plus A plus 1. This is already, this cannot be A, so it must be 1A. It must 10 plus A, okay? Right? So now you solve the problem, right? You have a 5, 6 plus 2A equals 10 plus 8. So A must be equal to 4, right? Yeah, A must be equal to 4 because this will, you know, after you simplify the equation, it'll be 6 plus A equals 10. Then A equal to 4, okay? You subtract both A from both sides, okay? All right, so you solve the problem. Now A equals 4, okay? Then C is going to be what? C is definitely is going to be, C is going to be 1, okay? C is going to be 1. C must be, okay? So we got the solution, C equals 1, okay? Yeah, let me go back to, let's go back to this problem again. How do we, you have to do step by step, you know, you have to go step by step, right? So you are given not many digits there. You have 3 different digits here. BA, AB, AB, and CAA, right? Let me repeat again. Okay, yeah. So first of all, right, you do the addition of the units digit. Then you have A plus B, right? Then you only have 2 possibilities here. Maybe you get more than 10, maybe you get less than 10. If less than 10, that should be equal to A. If more than 10, that'll be 10 plus A. can be more than 20. Is that possible? Is that more than 20? It's impossible. Why more than 20 is impossible? Because you change it 10 to 20, then you will see that 2b should be equal to 20. It's impossible. B is the largest possible value for digit is 9. Okay, so it's otherwise you can keep going. In order to get last digit is a, you can get a, you can get 10 plus a, 20 plus a, 30 plus, but the rest of them is impossible. So it's 2a, this is going to be 20 plus a, still impossible. Okay, so only possible case is this. Okay, so you have to solve the equation a plus b equals 10 plus a. Then you get rid of a on both sides, right? This is a, that is a, those two are canceled out. Those two canceled out, then this two canceled out, then you get double b. The b should be equal to 5. Okay. Then next step is to just fill in, replace b by 5. So make these. You already take care of the last column, so don't worry about the last column. Then you look at the second column, right? The second column, when you see that, you don't forget you get 1 from the computation of the units digit. Okay, from computation of the units digit. Okay, then yeah, then you have to add the 1 here. So this is a part. Don't forget that. Otherwise you get. Okay, then again, it's definitely greater than a, so you have to be 10a, 10 plus a. Then you solve for it. Okay. Yeah, then you solve for it. Oh, all right, I needed to do one more problems. Okay. So the last problem I want to discuss is I'm going to here's a computation, a circle, some numbers there equals another number equals, okay, I have a digits 0, 1, 2, 3, 4, 5, 6. Okay, I have 7 digits filled in the circles. Okay, circles, and this is 2 digits here. 7. Let me check. 7 digits must be filled in the circle, and this is not circle. We use a square. Let's change it to the square. Okay. Okay. Let's see the requirement. Okay. Each digit can be only used once, and please complete this formula. Okay, using those 6 digits. Okay. Yeah, this could be a 2-digit number. Okay. So this can be 2-digit number. So that's why you only have a few, only have a 1, 2, 3, 5 places, right? 5 either circle and squares. So, but you cannot use same digit twice. That's key point. Okay. Each digit can be used only ones. Okay. Okay. Now, how do you feel the? Yeah. How do you feel this? I think first of all, 0 and 1 cannot be in the product or in the division. Okay. So there's a, so how about this 0, right? For the 0, can you put it here? Can you put it here? You cannot. Okay. So cannot go there because 0 times any number will get 0. Once you get 0, and yeah, cannot be in any of these circles. Okay, 0 cannot be in any circles here. Okay, so the reason is that 0 times any number is going to be 0. Then in the square, there's a 0 there, right? So 0 will be used twice. No. Okay, 0, the number cannot be divided by 0. Okay, but the 0 cannot, if you divide by another number, it also gets 0. So you will get 0 in the square. So 0 cannot be. But this also cannot be in any of these places. Cannot be in any circle. Okay, it cannot be in any circle. Okay, so that's that is that's a point. Okay, so 0 cannot be any cannot be 1 cannot be the okay 1 can be okay 0 cannot be in the divisor, cannot be in here. So 0 cannot be here, but 0 could be here. Okay, it's possible any of the circles was in colors. Okay, any of the circles in the yellow. I'm sorry for that. But it's possible. It's possible here in yellow. Okay. Okay, so there is a limitation here. Cannot be any circle in the yellow color. I think it cannot be divided by 1. You get the same number, so cannot be. Okay. Okay. So then think about that. 2 times 6 is going to be 12. Okay. And also it's impossible. 2 times 6 is going to be 12. It's impossible to put there. The reason is 2 shows up twice. Okay. And just try a few times. 2 times 5. Now I'm trying to figure out what are the 2 digits you can use for the product. Okay. So after you try several times, you end up with 3 times 4 equals 12, and then 60 divided by 5. So use all the digits. So the solution is 3 times 4 equals 12, and that's 60 divided by 5. Okay. So you have to think about, yeah, exclude some cases. Then and then like a 2 times 5, you can try this. 2 times 5 equals 30, equals 10. So equals 10. Then you also, then you try to figure out the, you try to, 10. Then you already figured out the first, right? Then the remaining is impossible because this is 10, and then I don't think any digits can be, you already use a 5, 6, 2, and 5, 10. So how it's impossible too. Okay, this part it cannot find the digit. Okay, so just try many times, find out only 3 times 5 works. Okay, yeah. and the 2 times 4 does not work. Okay, because 2 times 4 is not it's going to be 8. 8 is not one of the digits. 2 times 3 equals 6. Okay, and the 6 never get to 6. 2 times 6 2 times 3 is going to 6. That's also impossible because it's not impossible. It's easy to check. Okay, you only have how many digits left? You already used 2, 3, 6. Then you have a 0, you have a 5, you have a 1. No matter how do you do the combination, doesn't work. Only this works. Okay, I know your brain is hurt, but so this type of problems are there's multiple choices at the very beginning. You have to exclude the one by one, okay? And sometimes you have to draw a tree, okay? Case 1, case 2, but some trees, some direction will be dead end, and then you can at least there's one path. There will be at least one path to the end, so you can get the answers, okay? Well, you have to use our brain cells to think about, okay? To think. That's why let's train your brain to think mathematics.